Thank you very much indeed. So let me just introduce myself. As was said, my name's Garth Gilmour. I joined JetBrains back in March as a developer advocate. So if I say anything that sounds like a product announcement, it's not. I'm just being silly, okay? So prior to March, I was a Google developer expert for Kotlin, and I worked for an Irish company for 10 years that specialized in software development and consultancy using Kotlin and TypeScript. And the news that I found out at 5:30 this morning is that if I wasn't here, I could be meeting the King or Queen. So the King and Queen are coming to where I live in Newton Abbey, just outside Belfast. And my wife is a local politician and got to meet them today. So I was woken at 5:30 with a little text to say, have left the boys to school, off to see the royal couple. Yeah. So I have been upstaged. You know, I thought that the talk at tea time would be my boys saying, Daddy did a talk in Chicago, but now it's going to be, Mummy got to meet the Queen because she just sent me a photo that I saw before I came into this room. So I'm just hoping that the gift shop at O'Hare is very, very good, okay? Because I have been upstaged, yeah, and I have an awful lot of ground to make up, but never mind, yep. So let me just talk about you guys for a minute. So can I ask, who develops on the JVM or who does mobile development? A few, yeah, good, maybe about a third. And who does front-end development in general? Who builds user interfaces? Oh, that's a goodly number, good. So we're in the target audience for this talk. That's excellent. So this talk is 3 parts. I've called them What, Where, and Why, Show Me the Code, and Alternative Approaches. So basically, I'm going to try and set the context for Compose, then show you a bunch of demos of increasing sophistication that will hopefully enable you to go out and start coding. So my uber goal is by the end of this talk, any of you can walk out of here, fire up the IDE, and start writing code using Compose Multiplatform. So you can let me know by the end of the talk if I've achieved that. And then we'll finish off with a little bit of chat about alternative approaches. I'm going to be throwing a lot of code and links at you, but as you know, the organizers are making all the slide decks available, so you will get this, yeah? And then there is a Git repo there that has all the code for all the examples, and the README has all the links in it. So there's no need to take photos or notes or anything like that. So part 1, I've called the What, Where, and Why. So we're going to be talking about Compose Multiplatform, and first of all, I have to introduce you to what that is, okay? So can I ask, who's met Compose before in any shape or form? Anybody at all? Nope, just one? Grand? Cool. So need to introduce Compose and then explain the multi-platform bit, because in these days of virtual machines and Docker and Kubernetes and serverless and so on, we're not entirely sure what that means. So presumably we mean more than anywhere there's a JVM, but less than all platforms everywhere, including the AS400 and the Commodore 64, yeah? So I need to explain what that term actually means. And then finally, why? Why should you care about Compose Multiplatform? Why might it be worth your time after this talk going out and having a little play? So if you're like myself, I flew over from Belfast 2 nights ago, and you're a little bit jet lagged. Here's the TLDR, okay? So Compose lets you create awesome user interfaces, yeah? Compose Multiplatform is produced by JetBrains. It's built on top of Kotlin Multiplatform, also from JetBrains, but very much powered by Jetpack Compose from Google. So the rest of this talk is going to unpack all of that. So here's a true story that you probably won't believe. It was 2 weeks ago. It was a Saturday morning. I was sitting at the kitchen table trying to work out how to start this talk. And I opened up Twitter, and this is the first tweet that I saw. So I'm going to make a claim you won't hear from any other talk at this conference. I believe that this talk was divinely inspired, because this was just delivered directly to me through the magic of Twitter. So I may have finally found an app framework that doesn't completely suck at desktop apps. It's actually quite good so far. JetBrains Compose Multiplatform. So I like this tweet, A, because it's complimentary, and B, because there's 2 things in there that might surprise you. Talking about desktop apps and talking about JetBrains. So if you've heard of Compose at all, it's probably through Jetpack Compose. Yeah? So Jetpack Compose is the user interface framework created by Google for Android development, replacing the XML-based approach that was there before. And there's the website, and a nice summary demo that they have on the website. So you can use this to create really nice, rich, fully featured user interfaces. So just to prove the point, here's some sample applications from the Android website. Here's the winners for a developer challenge that they ran, I think it was back in 2021, and they give a specification, and folks had a day or less to implement the solutions. So these are what people came up with in less than a day, which is quite impressive. And then things that you might actually use on a day-to-day basis. Well, here's a Slack clone here. And here's an application that you can use to track and watch your favorite television shows. Yeah. So Compose is a user interface framework that you can use to write really rich, nice-looking, fully featured interfaces. So what's Compose Multiplatform? Well, here's the website for Compose Multiplatform here. As you can see from the top left, it's from JetBrains. So what JetBrains did was they took the Compose user interface framework and they made it available on other platforms, hence the name. So the kind of functionality that we've just been looking at, you can now get that on the desktop, you can get that on iOS, you can get that on the web through WebAssembly, okay? And Compose Multiplatform was implemented on top of Kotlin Multiplatform. So we have both Compose and Kotlin Multiplatform. And this distinction can be a little bit confusing, so let me just explain what Kotlin Multiplatform is. So first of all, there isn't just one Kotlin compiler. Yeah, there's the Kotlin JVM compiler that produces bytecode, but there's also the Kotlin native compiler that produces a native executable. And that you could run on iOS or macOS or Linux or Windows and so on. And then there's a compiler as well that produces WebAssembly. So given that you have these different compilers, you can start sharing code across different platforms. So at the end of the day, Kotlin Multiplatform is all about code sharing. And we're trying to simplify cross-platform projects. So let's say that you've got a project, you're developing for multiple platforms. Well, you can share your networking code. You can share your data types, your classes, and your interfaces, and so on. You can share your validation, your business logic. You get the idea. Yeah, as little or as much as you like, as indicated in the diagram. So where it doesn't make sense, yeah, you can still use the standard native approaches to programming that you were always using before. So that's the idea of Kotlin Multiplatform. So because that was there, they were able to take Compose and port it to multiple platforms. So Compose for desktop is in production. You've probably used it already. Can I ask, who's used the JetBrains toolbox to install or reinstall any of the JetBrains products? Good few people? Yay, good. Yeah, so if you've used that, well then you've used Compose for desktop. So what about iOS? Well, support for iOS went alpha at KotlinConf a couple of weeks ago. And here's an example here. This is the talk where it was announced. And you can see they're taking a selfie of the audience using an application running on top of iOS. And that's the image viewer application, which is one of our standard samples. I do have it running here, but the environment that we're in, it doesn't like it when I jump in and out of PowerPoint. Yeah, so after the talk, come up to me and I can show you launching it and running it and so on. But this is the application that we're talking about. So it's an image viewer with built-in support for camera and mapping as well. So there's a little video of it running on the desktop. And you can see that to get it running on the desktop, we've just got our main function, because in Kotlin the function begins with main. I am contractually obliged to make that joke. Yeah. So we have our main function, and inside there we're invoking a function called application, and we're passing in a lambda, and then inside the lambda we're just saying image viewer desktop, and boom, off we go. So quite straightforward. So There's one other component that we need to introduce to finish the introduction, and that's the idea of multi-platform libraries. So we've said that Compose Multiplatform is built on top of Kotlin Multiplatform, and in Kotlin Multiplatform you have a lot more than just the standard tools and compilers and built-in libraries. You also have a huge and growing ecosystem of libraries for doing all kinds of stuff. And going through all of these, we'd still be here tomorrow. It'd be well beyond the scope of this talk. But just to give you a feel, there's Coin, dependency injection framework, there's libraries for doing database access, there's complete architectural frameworks for building applications using Compose, there's all kinds of libraries. So if you want to explore what these are, there's a curated list called Awesome KMM, which will just walk you through them. So that's a good place to go to just to see what's possible. And if you want to start playing with them, well, there's this little wizard that you can go to online. So you can specify the details of your project, the platforms where you want to see it running, the multi-platform libraries that you want to use, and it'll go out and generate the skeleton project for you. So that's a really good way to get started. So that finishes part one, which was our introduction. So these are the things I'd like you to take away. So Compose lets you create awesome user interfaces which run on multiple platforms. And these are the platforms that we're talking about here. Bearing in mind that the iOS support is still in alpha and the WebAssembly is still experimental. And Compose Multiplatform lives on top of Kotlin Multiplatform. So the one couldn't exist there without the other. So part two, show me the code. Yeah, let's actually go out and write some code using Compose. So I've been writing user interfaces since '95, if not before. I started out in C++ and MFC and so on. But the framework I can still use off the top of my head is Swing, Java Swing. That's as far back as I can go before my brain breaks. Yeah. So who ever wrote code in Java Swing? Yay, good. Anybody still doing it? Yeah, very good. Yeah, you're not alone, sir. There are an awful lot of people out there still writing Java Swing code. Yeah. So at the end of the day, you're always creating a tree of components. A user interface is always a tree of components. And whenever the components need to render, well, they in some way paint themselves on the screen. That has never changed. So the interesting bit is how do you create the tree of components? So in the beginning, we did this in this very procedural, kludgy, hard to maintain way, but it worked. And then around about the 2010s, things got declarative. So we said, look, we don't want to write this kind of procedural, build the tree one stage at a time type thing. Instead, we'll have some kind of file, back in the day an XML file, and the hierarchical structure of the file will reflect our tree of components, and we'll just declare what we want to have. So I first saw this with XAML in .NET WPF. So Compose is also declarative, but we don't have a separate file format. We don't put the user interface layout in XML or something like that, because that just didn't succeed. Far too hard to maintain, far too hard to keep in sync with the code, and so on. So in Compose, everything is done within Kotlin using what are called composable functions. So these are the demos that I'm about to walk you through. There's going to be 4 demos. The first one is just the standard push-a-button counter increments, just to give you a feel for the very basics. Then we'll have a slight evolution of that one, just to give you a little bit of information about how performance can be improved. Then we'll have this one here. So this has a text composable and a text field composable. And whatever you type in the text field, the text changes to that. You can increment and decrement the font size. You can change the color. So that will be our first major demo. And then we're trying to build up to this one here. So this is going to be our graduation exercise. So I have a microservice written in KTOR, and this accepts WebSocket connections. So this user interface here is going to connect to the server, download GOTO session objects, and then display the sessions. Okay, so if you can manage to make sense of that, by the end of the talk, well, then you're well on the way to understanding Compose. Cool. So let's start with the beginning. Let's start with the good old button and the counter. So we're going to be starting with desktop compose, and then we'll move things into mobile as we go. So for our desktop examples, this is the kind of shell that we're going to be using. So again, the fun starts with main, and we say single window application. So this launches the first window, and we pass in a window state object, which gives the window its initial size and position, and of course we pass in a title. And then we're providing a lambda as well, and inside that lambda we're saying material theme. So material is the original and therefore the most boring theme that you can get for compose. Other alternatives are available. And then inside there we're saying first example. So this is going to be our first composable function. So what does that look like? Well, a composable function is just a function annotated with composable. And a little compiler plugin runs against this. And it adds the ability for our function to emit nodes. Okay? So remember, at the end of the day, you always have a tree of components. Okay? So the tree of components are going to be emitted from this function. So what have we got? We've got a column that contains 2 rows, and in the first row we've got a text composable, and in the second one we've got a button composable. So the text composable, it is a style, so we've got a text style object here, and then we've got some text, and we're just going to print out counter is, and then the value of counter. Talk about that in a second. And then we've got our button with some text called push me, and we've got an event handler, so we're saying onClick equals lambda, and in the lambda we're saying counter plus plus. So what is counter? Yeah, well, you can see it declared at the top there. Counter is going to be our state, okay? So we're saying mutable state of 0. So we're creating a state object, and that state object is going to contain an integer, okay? So the state object is going to be observable. So whenever the value of the integer changes, anything that's watching the state object will be able to react to it. So you see here, we're going to say counter plus plus. So we're going to go to our state object containing an integer, and we're going to change the value of the state, okay? So anything that's observing that state will be able to react to it, okay? So what is observing that state? Well, the text composable, because you can see here we're saying counter is value of counter, okay? So this text composable is an observer, yeah, of the counter. And then this state object, we want it to be stored. So there's this thing called the composition, and that's where the compose framework is storing the tree of nodes, but it can also store other things as well. So whenever we say remember, yeah, we're passing some information to the compose framework, and we're saying, look, hold on to this for us, okay? So hopefully you can see now how it comes together. We have the button. Whenever you click the button, this little lambda here runs. That changes the value in the state object. The state object is observable. Anything that's observing the state will change. What's observing the state? This text composable here. Yeah. So the message gets re-rendered. So as we push the button, the value in the counter goes up. Everybody happy enough with that? That makes sense? Yeah. Cool. Very good. So we've learned some interesting things from our first example. So we're coding with composable functions, also known as composables. Yeah. Underneath the hood, these emit nodes into the tree. Okay. And this tree structure of nodes we refer to as the composition. And then we have state, which is being observed. And whenever the observed data changes, well, we need to rebuild all or part of the interface. And that's what's referred to as a recomposition. Okay. So this is the standard terminology that gets used whenever we're working with compose. So in any user interface framework, we want to maximize performance. And how do you maximize performance? By minimizing the amount of rendering that you do, okay? So let's say a change has occurred, okay? Well, we could just re-render the entire tree of components, okay? But that would be very, very bad for performance, yeah? So in any framework, you need to be smart about it, okay? So compose is very good at avoiding unnecessary work, okay? So compose tries very hard to avoid calling composable functions, okay? So whenever we're doing a recomposition, if it can skip a call to a function, it'll do it. So let's see a little example of this. So here's our next demo. So what we've got is, we've got a column, and inside here we've got 4 composable functions. So the counter display displays the value in the counter, okay? Person display displays a person object. Human display displays a human. Counter button increments the value of the counter. So it's the same thing as before, but we've got these 2 extra composables, the person display and the human display. So here's the type for person and the type for human. Apart from the name, they're the same with only one difference. Okay, so have a look at the code there and see if you can work out what the difference between the 2 types is. And then we've got 2 composable functions, one to display the person and one to display the human. And again, apart from the naming, it's just the type of the input that changes. And then finally, here is the thing actually running, okay? So you can see that on the initial composition, whenever we build the UI for the first time, both functions are called. But now, every time I hit increment counter, it doesn't bother to call person display, but it does have to call human display. So, can anybody guess what's the difference between person and human? What makes the difference? Well done, very good. So we're using val up here, yeah, and var down here, and that means that the person type is immutable. Very good, yes, yeah. So whenever you create a person object, it's not going to be able to change, okay? Because the data inside it is going to be fixed. On the other hand, with a human, if you create a human object, because we've said bar, you will be able to change the name and you will be able to change the age, okay? So if we pretend that we're Compose for a minute, whenever Compose is looking at re-rendering this UI, doing a recomposition, it'll look at the person display and say, hold on, as long as it's the same person object, we're good. You know, so I don't need to re-invoke this function, yeah? But with human display, a human is a mutable object. So it's possible that some other code somewhere, you know, change the name and or change the age. So human display needs to be called on every composition. That makes sense, okay? Yeah. So the Compose framework tries to do as little work as it can, and there are various ways that you can help it. Yeah. So this may sound very familiar, okay, because at the end of the day, if you're creating a user interface framework, you're grappling with the same set of problems, okay? So if you've done WPF, or if you've done Angular, or especially if you've done React, you know, you will have encountered these ideas before, okay? And especially with React, you can follow this nice little article here, and you can see there's a kind of one-to-one mapping between React terms and Compose terms, okay? So there is nothing new under the sun at the end of the day, okay? These same kinds of problems have to be solved, and they usually end up being solved in similar ways. So let's just talk about composable functions in a little bit more detail. Here's a slightly more advanced example. So we've got the idea of a scrolling box. So again, it's just a Kotlin function which has been annotated with composable. Annotating it with composable activates a little compiler plugin. This compiler plugin adds the ability for you to emit nodes, okay? So here we're going to be emitting a box, okay? And not just a standard box, a box that we've modified. So we've used modifier a couple of times before in the code, haven't made a big thing of it, but modifiers are incredibly important in Compose. As it says there on the right, they're how you customize and extend existing composables. So we're taking a box, adding some padding, and making it scrollable in both directions. And then inside the box, we're going to have stuff. Histogram, thermometer, panel of buttons, who knows, okay? So we're passing in this parameter called content, and it itself is going to be a reference to a composable function, okay? So whenever we go and invoke this function, it's going to emit other nodes into the composition, but we don't know what they are. You know, we just hope that whoever wrote that function did a good job. So we'll see this used in anger in a minute, okay? Hold this thought. Yeah, this will be back in a second. So let's do our third example here. And as I say, this is something where you type something into the text field and it gets displayed in the text. You can increment and decrement the font, and you can change the color. So it starts in the same way as previous demos, except that now we're using a view model. So can I ask who's familiar with the view model pattern? Few people, good, 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 yeah. So this is just the idea that your state and the event handlers shouldn't be embedded in the UI, because that's really bad for testing, okay? So we should take the state that's going to be displayed in the UI and modified, and the event handlers that change the text, that change the state, and they should go into a separate type, and that's our app view model. So here's our third example composable here. And you can see that we've got a scrolling box. I said that we'd see that in a second. And then we've got a column. And inside the column, we've got 2 rows. So the first row is going to contain some text. The second row is going to contain a text field. Sorry, 3 rows. And the third row is going to contain a panel of buttons. And we're going to be using the properties from the view model. So you can see that the text composable, that's going to display the content from the view model, and that content will be styled according to the style from the view model. And then we've got our text field, and inside the text field, we're initially going to display the content from the view model, but we also have an event handler, on value change, okay? So anytime you type something in the text field, we're going to change the content in the view model. And then finally, in that third row that I forgot about a minute before, we've got a panel of buttons. And we're just going to have 3 buttons, and the labels on the button are going to be ink, deck, and change color. And whenever you click on one of those buttons, we're going to call one of these event handler functions here. Okay? So the remaining functionality is all in the view model. So we've got 4 properties: color, size, style, and content. Okay? So content is what we've seen before. We're saying mutable state of. So content is going to be a state object which contains a string and is observable. Okay? So whenever you change the content, the observers can react. So in this case, that's the text composable. Okay? So if the value of the content changes, well then the text composable back in our UI, it'll react, it'll need to re-render. And then the content is going to be rendered in a particular style. So here we've got our style, which again is going to be a state and is going to be observable and so on. But interesting, yeah? You see here we're saying derived state of, okay? So that means that this is state, which is based on other state, okay? So we've got a text style object, and it's built using a color and a size. And you can see that color and size are themselves observable state. You know, that they are data that can be observed, okay? So let's say we change the color, yeah? Well, that change will be observed by the style. So the style will need to change, yeah? And that change to the style will then be observed by the text composable in the UI, okay? So in Compose, we can build state on top of other state. And then finally, you'll see that the color and size are private. So this might strike you as strange. You know, why would you make something both observable and private? And the answer is because we're going to change it in our event handlers. Okay? So here's our 3 event handlers here. Let's just pick one. Let's say decrease font. So we're going to take 2 off the size. Okay? So whenever we take 2 off the size, that's a change to the size. That state, that is observable. Okay? And that change will be observed by the style. And then the style will get recalculated, and that change will get observed by the text composable in the UI. Okay? So hopefully you get a feel for how everything works and things get put together. And then finally, remember we put it in the scrolling box. Just want to show you that the scrolling box does actually work. Okay? So if you were doing this in anger, yeah, and you were going to allow the window to be resized, well then you would worry that if you kept increasing the font size of the text, it would go out of the window and so on. So you'd want to add that scrolling functionality. Yeah? So just to prove to you that that composable does actually work as well. Brilliant. So we've got our third demo working, but everything we've done so far, we've done with Compose for desktop. And this is supposed to be a multi-platform framework, you know, so let's go mobile, to quote Bain. So how would we do that? Okay. Well, you can go out, and there's a template on GitHub provided by JetBrains, and you can open this up in Android Studio, and this will enable you to take a Compose UI and get it working on desktop, on Android, and on iOS. Okay. Now, in order to do this, of course, your machine has to be already set up for mobile development, and there's information in the README on how to do that. So if you're not already a mobile developer, that will be a job of work that you need to do. So whenever you open up the template, there's an app component, and this is the equivalent of main, okay? And by default, this just contains a button and some text and so on. But what you can do is you can replace that with your own stuff. So I took the demo that we just developed, and I plonked it in here, and I just made one enhancement, which is I'm going to call this function here, which will give me the name of the platform that I'm currently on. And then, having done that in Android Studio, it gives you the run configurations, so you can just go out and run it. So you can choose to run it on an Android phone or in the emulator. Here it is here. You can see it works perfectly well. Or you can choose to run it in the iOS emulator or on your iPhone, and it works perfectly well. Yay! So let me just say, I am not a mobile developer, okay? Very little time in my professional career has been spent on mobile. And yet, I was able to just get this working, okay? I have, however, spent an awful lot of time on desktop development. You know, that's my bias, yeah? So whenever I'm playing with Compose, I get something working on the desktop, and then I try and port it to mobile, okay? Your mileage may vary, okay? You may wish to go in a completely different direction, okay? But whatever direction you want to go in, Compose Multiplatform supports it. You know, that's the whole point of the thing. So, making a start on or off mobile, easier than you think. All the resources that you need, the templates, the tutorials, and so on are all available, and this is obviously a big thing. If you're a project that needs to support multiple clients and you're trying to reduce expense and code duplication, this is a big thing to have. Okay? So, our final example, this one here, the viewer. So this is going to download and let us view sessions that are running at GOTO, or at least the sessions that were available when I wrote the code for this app. So we're going to need everything that we've seen so far, but the point of this final demo is just to show you the multi-platform libraries in Anger. Okay, so to get this working, we're going to be doing networking. We're going to be doing marshalling, converting things to and from JSON. We're going to be working with WebSockets. We're going to be doing concurrency. Yeah, so we need these multi-platform libraries to help us. So how do they get used? Well, here's our first type here, GOTO session. And if you look at the final property there, we've got date of type local date. So I need to represent dates in a platform-independent way. So to do that, I'm using Kotlin X datetime. And then GOTO session objects, I need to convert them to and from JSON. So I annotate this class with serializable, and then I'm using Kotlin X.serializable, okay? Or serialization, sorry. So one type in, and we've already used two libraries. And then I want to send requests to the server and make a WebSocket connection. So in order to do that, I'm using Ktor, okay? Now, if you've heard of Ktor, it's probably as a server-side framework written in Kotlin with coroutines, okay? And that's true, yeah? But it also has a client as well. It provides a multi-platform client. So that's what we're doing here. We're creating the HTTP client, and we're installing a couple of plugins for content negotiation and to work with WebSockets. And then we're going to use this client to make the WebSocket connection and download the data. And it's going to do that using coroutines, okay? So coroutines are how Kotlin approaches concurrency. If you're not familiar with coroutines, don't worry. Just think of a coroutine as being a job of work. You know, it's a job of work that we can start up and cancel. So I've got my two functions here which do what they say on the tin, and because these are going to be working with coroutines, they need to be declared as suspending functions. So coroutines are a massive topic in their own right. We're just going to tread very lightly over them. But let's think about what would need to be done in any user interface like this, okay? Let's say somebody clicks on the button for Monday, okay? Well, we need to start a new job of work. We need to start a new coroutine, yeah? And that's going to run the side effect of downloading the Monday talks, okay? So hopefully that would run to completion. You know, we'd be all done and that would be it, okay? But let's say that we're downloading the Monday talks and the user gets bored, okay? So the user decides, oh no, I'm not going to be there on Monday, I'll be there on Tuesday. So they click the button for Tuesday, yeah? So we've got a new user interface event. That's going to cause a recomposition. We don't want to display the Monday talks, we want to display the Tuesday talks, okay? So this job of work, this coroutine that we started up, we now need to cancel it, okay? So how would this all be managed? quite easily, it turns out. Okay, so here's the code to do it. I'm not using a view model, A, to get everything on the slide, and B, because there's only one piece of state, and that's GOTO sessions. Yeah, so GOTO sessions is going to be a state object containing a list of GOTO session objects. Okay, and this is the thing that's going to be observed. So when the list of sessions changes, it needs to be re-rendered. And then the important thing I'd like you to focus on is this scoop object here. So you see we're saying remember coroutine scoop. So coroutines live inside a scoop. A scoop contains one or more coroutines. And coroutines live in parent-child relationships. Okay? So the parent waits for all the children to complete. If you cancel a parent, it automatically cancels the children. But this isn't just a normal coroutine scoop. You can see we're saying remember coroutine scoop. Okay? In other words, it's going to be compose that's going to create and manage this scoop object for us. You know, why does that matter? Yeah? Well, because if a recomposition occurs, then we can cancel all the coroutines. Okay? So whenever in this little function here, fetch sessions by date, whenever we say scoop.launch, we're launching a new coroutine to go out and use the client we saw a minute ago to fetch the sessions that we need. Yeah? But again, let's say the user loses their patience and they clicked on Monday, but then they clicked on Tuesday. Okay? So a recomposition occurs. Okay? And the coroutine that we launched here, we want that to be automatically cancelled for us. Yeah? And the good news is it just works. Yay! Okay? So this is a more complex problem, but it's not really more complicated code, you know, because compose is managing the heavy lifting for us, you know, and that's really, really good. So lessons from the example, concurrency is baked into compose via coroutines. Yeah? You have Kotlin Multiplatform providing all of these supporting libraries, and it's essential that they are there, you know, if you're going to do real world tasks. Because unless you're doing like a chess program or a Go program or something like that, it's not going to be completely self-contained. There's going to be some element of networking and so on involved. And again, this just works in mobile. Woohoo! Okay, so I was able to go to that template from GitHub, and I was able to put my code into the app component, and it just worked. Okay, I should say it just worked after 45 minutes when I remembered that you shouldn't say localhost in the URL because the microservice is now running on a different bit of hardware. You know, so this is now running in the Android emulator, and my KTOR microservice is running on my own machine. You know, 15 years I consulted, and it took me most of an hour to work that out. You know, whoops, 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 whoops. Yep. But that's my problem. That's not Compose's problem. Yep. Right, so that's the first two parts done. So in the first part, we introduced the whole area, hopefully. In part two, hopefully I've given you enough information to go out and start coding. You know, so after this talk, I'd really encourage you to get your hands dirty. There's the standard examples. There's the examples in my Git repo. Create projects from scratch. Really easy to get started. So finally, just to compare this to some alternative approaches. So of course, you have a choice yeah, when it comes to multi-platform UI frameworks. There are a goodly number of these out there. You know, you may be interested in Flutter, you may be interested in React Native. I have C++ friends who are still coding with Qt. I know an awful lot of companies who still have Java Swing code that they're maintaining and so on. You know, so there's a lot of these frameworks out there. So what about other? Okay, well, I'm not here to slag off other. A, because that's not what I do, and B, because I don't know enough about them. Okay, but what I can do is I can just give you some of the merits of Compose from my point of view. So first of all, it's all built on top of Kotlin, which is a highly popular, widely used multi-platform language, which is not JavaScript. Okay? Yeah. So having written a lot of JavaScript, this is something that I really value. Okay? Again, your mileage may vary. I have good friends who love JavaScript. Plus, if you're using the Kotlin native compiler and you're an iOS and so on, well, the clue's in the name, it compiles natively, you know, so that might help with any performance worries that you might have. But most importantly, to borrow a phrase from a completely different industry, when the fun stops, Stop. Okay? So what do we mean by that? Yeah. Well, you can use Kotlin Multiplatform with or without Compose. Okay? You can take things on a case-by-case basis. Okay? So in some cases, it might make sense just to share data types, validation code, and business logic. That's it. Okay? In other cases, you might want to share everything up to and including the entire user interface. Okay? So whenever you're using Kotlin and Compose Multiplatform, it's not a binary choice. It's not all or nothing. It's not a zero-sum game. You know, you can do whatever you think is best on a case-by-case basis. So just to wrap things up, what is Compose? Yeah, it's a user interface library which is modern, productive, concurrent, fully featured, and incremental. You know, you can learn it one bit at a time. Yeah, what's the right way to eat an elephant? One piece at a time, one spoonful at a time, okay? You don't have to learn all of Compose in one go, and that's good, you know, because the frontier is being pushed back faster than you can learn it. You know, there's a huge amount of innovation and creativity going on at the moment. And what do we mean by multi-platform? Well, we mean mobile, as in Android and iOS. We mean desktop, yeah, as in Windows, Mac OS, and Linux. And we mean the browser via WebAssembly, you know. So at the moment, that's what we mean by multi-platform. And finally, why? Well, you're building on a popular and well-supported language. That's Kotlin. As we've discussed, you have both Kotlin and Compose multi-platform. You're not giving up access to the native capabilities of each platform, you know, and that's really, really important. You know, you do you, you know. Use what works best in each particular case. You have access to a really rich ecosystem of libraries and tools, and you can leverage work being done by other communities. So, for example, at the moment, the Android community is on fire, okay? They are pushing out tutorials and components and libraries and templates and so on, okay? And the point is, you don't have to be a member of the Android community to take advantage of all of this work. You know, it just comes to you, and that's really, really good, yeah? So you can easily go out and support new platforms and reuse components and so on, you know. So this is really the value proposition here for Compose multi-platform, okay? So I wanted to live code some of this, but jet lag. I wanted to run some examples, but the setup doesn't really permit it. So I'll be about, you know, for the rest of the conference, yeah? So please, if you'd like to see any of this running, if you'd like to see some code changes and have a little play and so on, just find me, okay? So yeah, that's my show. Thank you very much indeed. Cheers. Thank you. Cheers.